most recently, we were able to come up with a new synthesis method to actually tune the capacity of the hydrates, and this was really a breakthrough for us. It was back in 2004 when we published in Science with our colleagues from TU Delft that you could reduce the storage conditions, that is the pressure conditions required to store hydrogen in the clathrate hydrates, by adding promoter molecules. These molecules actually help stabilize the lattice. And this was very exciting that we could reduce the pressure, but there was a big drawback on this, and this was really hanging around for many years, from 2004 right up to just early this summer, when people from all the groups around the world working on clathrates were trying to find a way of, now you can actually reduce the pressure conditions, how can you increase the storage capacity as well? And that was a major stumbling block for many groups, including our own, in which it was then announced at the conference, the international conference in Boulder, that in the plenary talk, that in fact storage when you have promoter molecules can only get you 1% or less. So that really isn't very attractive at all. And so since then, we actually worked on a new synthesis method, and this involved our 2 undergraduate students, and actually came up with this breakthrough method where we could now use the promoter molecules to reduce the pressures required for storage, so that we're much more attractive than the pressure conditions that you would need without the promoter molecules. That is 200 megapascals is the usual pressure. But adding promoter molecules, you can reduce the pressure requirements by orders of magnitude. But we could also increase the storage capacity, in this case up to 3.48% currently. So this was a really nice result for us that we just later this September published in JACS. And again, we were able to determine this from our Raman spectroscopy, where we could clearly see the direct evidence of clusters of 4 hydrogens within the cages, as well as gas analysis, where we actually measure the amount of hydrogen coming out of the cages.